The accompanying data represent the approximate population in millions of the 20 most populous cities in the world. Use these data to construct a frequency distribution with the first class of 7.0 to 7.9. Right, so I'm going to create a table. Now the first class is 7.0 to 7.9. Since the first class ends at 7.9, the next one would have to begin immediately after at 8.0 so that there's no gaps and no overlapping. Now, once I have two successive lower class limits, the 7.0 and 8.0, I can find the class width. The class width is the difference between the two successive lower class limits. So the difference between 8.0 and 7.0 is 1.0. Well, once I know that class width, I can add that class width to each lower class limit to get the next successive lower class limit. So I have 8.0. If I add 1.0, I get 9.0. If I add 9.0, if I add 1.0 to that, I get 10.0. Then 11.0, 12.0, and 13.0. Well, we could do the same thing with the upper class limits. Once I know the first upper class limit and the class width, I can just add the class width to each. So I have 7.9. If I add 1, I'll get 8.9. If I add 1, 9.9. I add 1, 10.9. I add 1 to that, I get 11.9. Add 1 to that, I get 12.9. And 1 to that, I get 13.9. Now our next task is to fit the data items into these individual classes. To do that, I'll take a tally. So 13.7, that fits into our last class. I'll just put a mark. 13.5 into that last class. 13.1, 13.1. Now 12.7 fits in the class before it, the 12 to 12.9. 11.5, 11.2, then 10.4, 9.8, 9.7, 9.2, 8.9, 8.4, 8.4, then 7.8, 7.8, 7.8, 7.6, 7.3, 7.1. So my frequency would be, if I add the tally marks, I have 6 data items in that first class, then 3, 3, 1, 2, 1, and 4. That would be our frequency distribution.